All right, so this is the last topic of the first unit, topic 4, and it's surface at an angle type of problems. Now we've done angle problems before. That would be tension, and then finding friction, with an applied force at an angle. And so I'm just going to quickly run through those different scenarios with you. So the first scenario was the one with tension. So you have an object hanging from a ceiling at an angle, right? And so we had the weight. This is not a free body diagram. Again, this is just quickly running through all of the different types of angle problems you've had so far and where we've used angles before. And then this was the tension total. And then you were told to take, remember, weight and the tension total were equal to each other. So you were told to take the tension total out and make a right triangle. And so we have tension 1, and tension 2 were put on the same side. And so we ended up with a triangle that looked something like this, where you had T1, T2, T total, and your angle. And so this was one of your angle problems where you had to use trig to solve. And then the other one was when you were pushing an object on a surface. So we have an object, and you were pushing maybe down on the object with an applied force at an angle to the horizontal. So there's your angle. And we ended up breaking that component down into an fx and an fy direction. So fy, fx, angle, and then fa. So that was those were your two angle problems that we've done so far. But now we're going to look at changing the surface and putting the surface at an angle and seeing how that affects the problem. All right, so let's build that scenario up. So we have a hill, and let's just say on this hill we have a sled. Since we've got all that snow, super excited. So we've got this sled, and on the sled we have a kid, super excited to go down the hill. So there's your kid going down the hill, and the hill is at an angle, and generally the angles of hills, even some of the steepest hills you've been on, are relatively small angles. So let's just make this one at an 8-degree angle. Okay? So let's think about the free body diagram here, and then we will finish up the problem on another video. But let's think about the free body diagram that we have going on here. All right, so we've got the kid, the slope is at an angle, so we're going to go ahead and draw this free body diagram with the slope going this way now. Weight is still going straight down towards the center of Earth, so that doesn't change. And you can still find weight the same way, mass times negative 9.8. That does not change at all. The normal force is affected. You see, once I lift the kid on the sled up at an angle versus being flat, I'm actually changing my normal force. I'm actually decreasing it. So my normal force is going to be a little bit smaller than the magnitude of my weight. Which is why the sled actually slides down the hill, because weight is greater. So that force pulling down the hill is a little bit bigger. All right, now what changes, let's just assume we don't have friction in this case. What changes is your net force. You see, the net force actually is a combination between the normal force and your weight force. And I'm going to draw in the vector for your net force on the sled, because I don't want to draw it in my free body diagram. And this is our net force. So our net force is going to go this direction, which is a weird direction for us. We haven't done a problem where we're having the net force go at an angle. Usually our net force is horizontal to the ground. All right. And so the case comes with, well, how do I find the net force? Well, you have an angle, so chances are you're going to have to use some trig. All right. And if we were to look at this from a geometric standpoint, and I play around with a couple of different things, I'm going to show you guys how that 8 degrees can actually be applied to the weight vector. All right, remember, the reason that the sled slides down is because of weight. The reason it doesn't go through the floor or the surface is because normal force is strong enough to keep it above the surface. Okay, so let's just see how we rearrange vectors, or how we change vectors to manipulate them to figure out F net. So F net, that is parallel to the surface. So what I'm going to do is I'm going to redraw F net right here, and I'm going to call it, I'm just going to, for argument's sake, we'll call it F net. All right, so I moved it from this location on the slope, so right here, to down here, but it's still parallel. So this line and this slope are parallel to each other, or that vector. Okay, and then I'm going to draw another vector in that is equal but opposite the normal force. Equal but opposite the normal force. And so we'll give those little names in a second here. But those are actually pieces of the weight. So what I'm doing is I'm taking the weight force and I'm breaking it up into a downward component and an over component. You can see there's a right angle right here. Now, this triangle somewhat matches that triangle, that idea. So you have your applied force, and then what we did was we found components of the applied force. We called them Fx and Fy. So what I'm going to do here is, just to keep these guys kind of similar, is I'm going to take this triangle out of the picture, and I'm going to draw it so that it sits nice and flat on a surface. And you see your weight vector right here. This is your weight vector, becomes your hypotenuse. And your F net right here kind of matches the x direction. So what we're going to do is we're going to call this weight x. And we're going to call this weight y. Now you may ask yourself where the angle, that 8 degrees, goes, and I could show you all the geometry that goes along with this, but the 8 degrees is going to go right here all the time. It's always going to go right there, that angle right there. So that angle is congruent to that angle. And I can show you the proof, like I said, if you want to see it. All right? And so this is what our focus is going to be on, because ultimately, what do we want to find? Ultimately, we want to find F net. All right? So that's going to be the next video.